Hi girls, so this is going to be a video about differentiating exponentials. A couple of warnings. I'm filming this outside, so let me know if there's a lot of like wind noise or anything like that. And I'm also thinking about how to make these videos better in terms of making them clearer for you to take notes from and things. So if you come up with any ideas, please let me know. So this is about differentiating exponentials. So we've been talking about logs a lot in class lately, which are, remember, the opposite of exponentials. And remember, an exponential is something like this. So it's like y equals a to the power of x, right? The fact that it's base to a power, the power is, another word for that is the exponent. And so that's why we call it exponentials. So we're going to start with y equals 2 to the x. Okay, so there is a graph of 2 to the x, right? And I've just done that through Desmos. Now, at this stage we don't know how to technically differentiate it, so I'm going to use the magic of technology and differentiate it for you. Wow, amazing. So, you've got in red there, 2 to the x, and in blue, if you believe in computers, which we should, because they're going to be our overlords one day, we've got the derivative of 2 to the x. Now, I want you to notice the shape, okay? So, hopefully you believe me when I say that the shape is essentially the same, right? 2 to the x looks exactly like 2 to the x, basically, except it's a bit below, okay? So, that's nice. I wonder if we can do anything with it. I mean, of course we can, otherwise I wouldn't be here and now, but let's think. Seeing as 2 to the x is, looks the same, is quite nice. What about 3 to the x? Not surprisingly, 3 to the x looks like 2 to the x. It's a bit different, but it looks the same. The thing that's different is, that's right, that it's steeper. And you'll see here that obviously I'm about to take the derivative again. So let's do that. And there we have it. And you can see that again, the shape of the derivative of 3 to the x is very similar to the shape of 3 to the x, except this time it's a little bit above, right? I'll go back. So we saw that 2 to the x, derivative the same, slope is below, sorry, derivative is below. 3 to the x, slope is the same, derivative is above. So hopefully you're asking yourself, can I find, that's a really great question mark here, so can I find some number, y equals question mark to the x, where the curve is identical to the derivative? And the answer is, of course I can. And the answer is that it is a nice number for exponentials called e. Right? And I'll tell you that e is, I think it's 2.718, something like that. But it is a number between 2 and 3. Let's get some graphs up. So there's e to the x. Okay. Nice shape, exactly what you expected. E is a number between 2 and 3, so it's steeper than 2 to the x, but shallower than 3 to the x. And then, this is another nice bit of math magic. Now, you don't have to believe me, because it's definitely true, because you can see the colours are still showing, so they should both be there. But you can see that the derivative of the exponential exactly overlaps the exponential. So that gives us a formula. And let's pick a nice colour for formula. I don't know, let's try purple. No, I'm not in love with purple. But, So we know that the derivative of the exponential function is in fact the exponential function. And that is why the number e is so special, so beautiful, right? So what I'd like, so this is, the proof of the thing. Now the question is, well, how do we do it in more general circumstances? So obviously the things we're going to need to do are we're going to need to be able to apply product rule, chain rule, quotient rule, and so on. And I'll just do a couple quickly here for you. So let's say that y is e to the 2x, and we want to differentiate this So now this is like the chain rule. So it's equivalent of something like this, right? Where it's like a function, an inside function, all to a bigger function, right? Now here, the inside function is like the e to the x, and then the bigger function is the square, right? So I could write this as y equals e to the x squared, using index laws. So how do I differentiate that? I bring down the power. Now, no, this is a bad explanation, in fact. Sorry, let me pause for a second. Now, unfortunately, I can't rewind, so I'm just going to have to try and re-explain. So let's get rid of this here. Let's just start again. Okay. Now, the way we need to think about it is we need to think about the 2 to the x as like a separate function. So we take the derivative of e to the 2x, right? Let's get rid of the 2 and start again. So we take the derivative of e to the 2x. Now, we know the derivative of e to the x never changes, so it never changes. And then we multiply by 2. And that is the derivative. Let's do one more. Let's say that y equals x e to the x. Okay, so we could call this here the first function, this here the second function, and apply the product rule. Where the derivative of the x is e to the x, and we do inside plus outside, so we get y dashed is e to the x plus x e to the x. Okay, I'm going to stop the video there, and we'll go on from there tomorrow. I hope you enjoy the photo of my pet chicken, and I hope you complete the quiz, and I'll see you tomorrow.